Hello, everybody. This lesson is going to be on radar charts, and radar charts aren't really seen unless you're looking at usually meteorological data or cyclical data. And by that I mean what radar charts are special at, or what they're amazing at, is rather than moving across like an ordinary graph, line graph. It moves across, as time goes on, the information moves along with it. Okay, so Friday, Monday, Tuesday, Wednesday, Thursday, Friday again. You just see how this information will just keep on going in a continuous line. What radar charts are brilliant at is rather than moving across, they pivot on a point. And so they spin around. Rather than moving across, they actually spin around. And so, rather than having an x-axis, they have a point. And every line or bar starts at the same point until it eventually goes back into its original point, like a clock, effectively. And so, for things, this radar chart talks about Canberra temperature. We see that the first line represents midnight, and we see that the axis, the units are on this first line, the 12 o'clock line on a clock. Will give you the axis. And those lines, rather than moving across in a normal graph, we have to follow them around the whole chart. We have to follow them around the whole chart if we want to get accurate data. And then we'll come back to its original point. So here we say the original at midnight, it's 16 degrees. At 3 a.m, we look over here and say, well, where does that actually fit? We have to trace it back to, that'll be probably about 14 degrees. What am I saying? Maybe 15 degrees, I beg your pardon, thereabouts. If we look at 6 a.m, we see that that's that point there. We still have to trace that back to the original line. So that goes through, and we're still looking at about 15 degrees. Look at 3 p.m, it's up here. Now, for us to know what temperature that is, because there's no axis units, we have to go all the way around and find out up here if that's 20, that's 22, that's 24, so that would be about 23 degrees. And that's what radar charts do, is they pivot around the point, but you need to make sure that you have one of these circular setups, like a blank one up here if you're going to do an accurate radar chart. Radar charts are quite difficult to do from scratch, and so for the most part what you'll end up with is a blank chart like that you'll have to fill in. So if we look here, I'll just start by putting in the 12 o'clock line, in other words the first set of units. The time goes around the day, and we see speed goes from 26 to 33 to 37 to 36. So we need to go as low as 26 and as high as 44. So if this is 0, 2, 4, 6, 8, 10, 12, 14, 16, that's not going to work. How about we go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. That's a bit more reasonable. So I'll put that in. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. And then we can begin with our times. So this is over a 12-hour period, and so we can start filling in as we move across. So if this is a 12-hour period, you would hope that this is 12 o'clock, and then that's 1 o'clock. Oops, I'm going to do it. At 3 o'clock, so that'd be 1 o'clock, and that'd be 2 o'clock. Scratch that, I beg your pardon, and so forth. So remember, as a bit of a summary, radar charts, they start off on the 12 o'clock line, or the top line here. They start off with the units and they work around in a circle and then back to the original point. And what they're really, really good at is doing data over a cycle. So basically stuff over a day that starts again the next day, or over a year, anything that goes back over the top. Thank you very much.